Hello, this is the January 2025 Regents exam for Algebra 1. This is the third in a series of videos going through the problems of this exam. So we've already done a video on numbers 1 through 7. Okay, that was our first video. And then our second video was problems 8 through 11. And now we're going to finish up this page doing problems numbers 12 through 15. So here we are. Let's get into our adjustment here. Okay, and here we go. So this first question asks, okay, there it is. Okay, the expression x with an exponent of 2a plus b is equivalent to. Now, if you know your exponent rules, this problem is not very difficult at all. So I'm going to give you the answer, tell you why the exponent rule works, and then move along. Okay, so the answer to this question is choice 3. Excuse me. Okay, and I'll tell you why. Okay, because first of all, we don't really have too many rules for adding exponents. Okay, or adding exponential expressions like choice 1 and 2 does. Okay, but what's going on here is this. Okay, let me give you an example of something a little bit similar so you'll understand. All right, so if I have x to the 5th and I multiply times x to the 3rd, okay, and if you know your exponent rules, you're going to get x to the 8th, okay, because there are 5 of them here and there are 3 of them here. And when I add them all up, when I multiply, I get x to the 8th by adding the exponents. So what's happening here in this problem is you are taking the a and you are taking the a plus b and you're adding them together. A plus b gives me 2a. 1a plus 1a is 2a plus b, which is what we have right here. All right, so working the problem a little bit backwards to help explain it is what I just did. If I try to do the same thing on choice 4, I'm going to get x, okay, a plus b plus a plus b. A plus b plus a plus b gives me 2a's plus 2b's, so that would not be exactly correct, okay? So there's my explanation of that particular question, and we're moving forward now on to number 13. And number 13 says the inputs and outputs of a function are shown in the table below. So x is our input, commonly known as our domain, and f of x is our y, or our output, commonly known as our range. Okay, and it's asking what type of function can be described above. So if it was linear, it would be addition or subtraction. Right? And clearly that's not what we have here, because if I go down to the numbers that are a little more manageable, if I add 0.25 and 0.5, I would get 0.75, and that's not 1. So it's definitely not linear. Okay, quadratic is that U shape, which means when you have a table, you would have a vertex in the middle, and then your points would kind of be symmetric on either side, and that's not happening here either. Okay. Absolute value is very similar to quadratic, except that all of my y values would then be positive. Okay, and exponential is our answer because exponential means that we are multiplying or dividing, because division is a form of multiplication. And when I look up here, if I multiply 0.25 by 2, I get 0.5. If I multiply 0.5 by 2, I get 1. If I multiply 1 by 2, I get 2. And clearly then it's an exponential function because it is multiplication. Okay, number 14. Stephanie is solving the equation x squared minus 12 is equal to 7x minus 8. Her first step is shown below. So I'm going to just rewrite this over here in my workspace. X squared minus 12 equals 7x minus 8, okay, which is what we have here. And her next step is to get x squared minus 4 equals 7x. So if the 7x is over here, that means she must have moved the 8 to the other side. Okay, and when she moves the 8 to the other side, she gets x squared. Negative 12 plus 8 is negative 4, and that equals 7x, which, lo and behold, is what we have here. So what did she do? She added the 8 to both sides. Now, what property justifies that? The associative property allows us to group, okay? It allows us to group numbers, G-R-O-U-P, that says, okay? It allows us to group numbers like 2 times 3 times 5. Let me show you, okay? It could be like this. 2 times 3 times 5 equals 2 times 3 times 5. And it doesn't really matter if you group this way or you group this way, you're still going to come out with an answer of 30, right? The commutative property allows us to change order, okay? Meaning that 2 times 5 is the same as 5 times 2. And clearly, that's not what we did in this particular problem. So 1 and 2 are not correct. The distributive property is our good old favorite, right? We have something on the outside of parentheses and we're multiplying on the inside of the parentheses, and that's not what we did either. So by eliminating all the wrong answers, we come up with the right answer. But why? Addition. What did we do? We added the 8 to both sides, okay? And when we did that, we still maintained equality or equal measures on both sides. So this is the addition property of equality. Add the 8 to both sides, and we get this -4. Okay, 15. Sum. What is the sum of 8 radical 3 and radical 3? So sum means that we are going to add. Okay, and we are adding 8 radical 3 plus the invisible 1 radical 3. So this is what our problem looks like. 8 radical 3 plus 1 radical 3, okay, is equal to, now this is like 8x plus 1x would give us 9, but instead of x, we use the radical 3. And that's my answer, plain and simple, 9 radical 3. Now, if for some reason you forgot how to do this problem and it comes to be the Regents' Day, what you do is you take your little calculator, your big calculator, and you type in every single one of these answers, okay? And you write down what the decimal is, okay? And then you add these two together, right? Or you add these two together first. You get 8 radical 3 plus radical 3, and you get a number. And whichever number matches the 4 choices, which would probably be 9 radical 3, should be 9 radical 3, is going to be your correct answer. Okay, so that's it for this video, and I'll see you on the next one.